Welcome to this presentation on gradient checking, ensuring the correctness of backpropagation. In machine learning, especially in deep learning, we rely heavily on backpropagation to compute gradients and update model parameters. However, implementing backpropagation manually can be tricky, and even a tiny mistake in the formulas or matrix operations can completely break the learning process. This is where gradient checking comes to the rescue. What is gradient checking? Gradient checking is a debugging technique used to verify whether the gradients calculated using backpropagation are correct. It does this by comparing the analytical gradients, that is, the ones computed using calculus with numerical gradients, which are computed using a simple mathematical approximation. How numerical gradient works: to estimate the gradient of a parameter using the numerical method, we use a small value epsilon, denoted as epsilon, usually something like 1e7. For each parameter theta, we compute j theta plus epsilon minus j theta epsilon divided by 2 times epsilon. This gives us an approximate gradient. If this value is very close to the gradient obtained from backpropagation, our implementation is correct. Why gradient checking is important? Even professional researchers end up making mistakes while implementing neural networks. A wrong gradient means the model will update parameters in the wrong direction and training will fail silently. Gradient checking helps us gain confidence that our backprop implementation is right before we start the training process. How to perform gradient checking step by step. Step 1. Initialize your model parameters randomly. Step 2. Compute the cost and the analytical gradient using backpropagation. Step 3. Compute the numerical gradient using the finite difference formula. Step 4. Compare both gradients using the relative difference formula. Absolute difference between the two gradients divided by the sum of their absolute values. If the result is less than 1e7, your gradient is correct. If it's higher, there might be a bug in your backpropagation code. When to use gradient checking? Gradient checking should only be used during debugging, not during training. It is computationally expensive because it needs to evaluate the cost function individually for every parameter. Also, it should be done without regularization, without dropout, and without any randomness to ensure fair comparison. Common mistakes to avoid: using epsilon that is too large or too small can give misleading results. Forgetting to disable optimizations like dropout can also lead to mismatches. Always ensure both gradients are computed under the same conditions. Conclusion: gradient checking is like a truth detector for your backpropagation logic. It won't improve your model accuracy, but it ensures that your model is capable of learning correctly in the first place. So, before trying to train a complex neural network, always apply gradient checking once. It may take a few extra minutes, but it can save hours or even days of debugging later. Thank you for listening.